Okay, now we're recording. Popped up there. So yeah, again, today we're going to go over section 2.3, a little bit of 2.4. I don't think this is going to take that long. I think this is going to be one of the shorter sections. It really is a review section. It's not typically a college algebra topic. Straight lines, linear lines are a pre-algebra topic. So I kind of teach this like it's a review, but if you feel like I'm going too fast, let me know, and I can find you a really true lecture on this topic, a true, more in-depth kind of pre-algebra lecture. And I don't mind sending it to you. It's not a big deal, and don't feel like you're not smart enough or anything like that. It's just one of those where the sequence of things lines up where I need to go over college algebra, but I just won't go over it as in depth because I assume you've at least seen it before. So 2.3 is on linear functions. Linear functions. So linear, of course, means straight line. So we're dealing with straight line functions. And before we really lecture on straight line functions, we have to talk about every like kind of thing a straight line has, which is slope. Okay, the slope of a line. Now, I know hopefully you've seen this before, and it's not the first time, but there's a lot of ways we can kind of talk about slope. First off, we use the letter M, right, for notation. I have no idea why. You're more than welcome to Google it. I feel like I've Googled it in the past, but I don't remember why. It uses slope, but usually, typically when I ask students, hey, when you hear the word slope, what do you think of? They'll yell out y equals mx plus b, right? Well, the m in y equals mx plus b is slope. We'll get to that equation here in a minute. But really, the equation boils down to rise over run, right? It's the slant of a line. That's another way to think of it. I'll come back to that. But let's talk about rise over run. So before you get to the actual equation, which if you know it, that's fine. But before you get to the actual equation, you can use the rise over the run to find the slope in a very basic way. Kind of when I say elementary, I just mean basic, not elementary like school. But let's say we've got some line out here in space, x, y there, and we know this line goes through two coordinates. Let's say it goes through negative 1, 1 there, and it goes through, let's say, 4, 3. Okay, so we know the line goes through negative 1, 1, and it also goes through 4, 3. Well, if we draw a straight line, this is a linear function. All you need is 2 points for a linear function to draw the line. So we've got this nice straight line. If we want to find the slope, we can just use the rise and run aspect, right? This thing is going up and to the right, so therefore it's going to be a positive slope. If it was going down, it would be a negative slope, okay? But it's going up and to the right, so it's a positive slope. If I'm going to use rise and run, I always start at the leftmost coordinate. And the goal is to stair step your way to the next coordinate that we know. Okay, so if I want to go from here to here, the rise, I would go up 1, 2 units, right? 2 units up, because it goes from a positive 1x to a positive 3, I'm sorry, a positive 1y to a positive 3y, right? So it goes up 2 units. And then we've got to run. So let's see here. We're going to run 1, 2, 3, 4, 5. We run 5 units to the right. So we're rising 2, we're running 5. So the slope of this line, the slant of the line, is just 2/5, okay? So that's a way to find the slope without having to do the equation, which I haven't got to yet, but I'm hoping that you have seen that before, okay? It's hopefully not your first time to see this. So let's look at the equation. The equation really comes from the change. The slope is all about change. So if you do plan on going on to a college algebra class, or even maybe a little bit of a pre-cal class, they're going to talk more about slope being change and how it describes a tangential line, but it's all about change. So really it's the change in the y. Now we use delta for change in mathematics. So delta y over delta x. That delta means change, okay? So delta y over delta x is the change in the y over the change in the x. And the way we find change algebraically is just from subtraction. So this is what a lot of times students yell at when I ask them slope. They'll go, y2 minus y1 over x2 minus x1. And what they've remembered is the slope or the equation for slope, okay? Given 2 points, the equation for slope, right? If you're going to use this, it's got to come from 2 separate coordinates, x1, y1, and x2, y2. And the order, it's not that it matters, it's that the first coordinate has to be first or second, and the second coordinate has to be first or second, okay? This is one coordinate, and this is the other coordinate, okay? You can't mix and match there. Okay, so let's use the equation to show that you'll get the same exact slope, but without doing it visually. So we know that this line goes through, was it negative 1, 1, and 4, 3. Okay, we know this line goes through negative 1, 1, and 4, 3, and we're going to find the slope using the equation. So I'm gonna kind of notate which one of these is x1, y1, and x2, y2. So I'm going to call this one x1, y1, and this x2, y2. And then I'm just going to pop it into the equation. Well, m equals 3 minus 1, right? y2 minus y1 over 4 minus a negative 1. Well, 3 minus 1 is 2, right? 4 minus a negative 1, that's 5. Boom. We got the same exact answer, right? Because it doesn't matter if you want to find it equationally or if you want to find it visually, that's fine. Sometimes it's hard to do it visually because you don't have graph paper, or maybe it's really big number or something of that nature, okay? So we just plug it into the equation, okay? Question. And again, hopefully this isn't the first time you've seen this, okay? This is just kind of a Zoom review here. Okay, so let's look at, let's just find a few different slopes with the equation now. And I'm just going to give you coordinates, so we're not going to draw them. You can draw them if you want, but we're not going to draw them. So let's say we're going to do A, B, and C. And I want you to find the slopes of these three with this equation. So the first slope, let's say we had negative 2, 5, and 2, negative 3. So find, and this is how the book gives it actually. It says, find the slope of the line passing through each pair of points, or state that the slope is undefined. We'll get to one of those here in a minute. Then indicate whether the line rises, falls, or is horizontal or vertical. Okay, so let's look at another one. Let's say I had 3, 4, and 7, 4. And then lastly, I've got negative 1, 2, and negative 1. Let's say negative 1, 5. So try those three. I'll give you a few minutes. Just pop them into the equation and see what you get for the slope on each one of those. Okay? See what you get for the slope on each one of them. Let's start on these. So we're going to say m equals, I'm going to say x1, y1, x2, y2, right? Negative 3 minus 5 over 2 minus a negative 2. So I get negative 8 over 2 plus 2, right? 4. So I got negative 2. Did you guys get that? I could be wrong. I make goofy little mistakes sometimes too, right? Now, that negative, though, tells me that it falls, right? This slope is going to go down 2 over 1, right? That really, if you want to think of it in slope form, it really needs to have a rise and a run, but it would go down 2 and then run 1. So wherever the coordinate starts, it's going to go down 2 and then over 1. Okay, so this means this thing's going to rise. I mean, fall, not rise. Okay. Now let's look at the next one. So we got m equals. And now I'm going to still consider this x1, y1, x2, y2. So I get 4 minus 4 over 7 minus 3. So 4 minus 4 is 0, divided by what, 4? Well, 0 divided by anything is just 0, right? If I have no money and I divide it into my 4 kids, I don't have 4 kids, but let's say I had 4 kids. If I have no money and I divide it into 4 kids, they all get no money, okay? So this would just be 0. Well, what kind of line has a slope of 0? Well, it turns out, now check this out. The x value changes, right? So the up and down changes, but the y value is not changing. So if we think of a line where the y value doesn't change, if I make just a quick sketch of this isn't going to be perfect. But if I go 3, 4, let's say 3's here and 4's here. There's my first coordinate, right? And then I go 7, 4, 7 somewhere out here. And look, the y didn't change. Oh, we've got a flat line here, right? Boom. We've got a horizontal line. So we've got an m equals 0, which is a horizontal line. And it turns out all horizontal lines will have a slope of 0, okay? All horizontal lines will have a slope of 0. And if you kind of think about this, look, the positive numbers are up here, right? The positive slopes are up and to the right. The negative slopes are down and to the right. Well, 0's in between the negatives and the positive. Okay, that's kind of a way to do it. Okay, so let's look at the last one. M equals. So now we've got 5 minus 2 on top, and then negative 1 minus a negative 1 on bottom. Well, 5 minus 2 is just 3. Negative 1 minus a negative 1, no, that would be 0, right? Now this is different. We've got a 0 on the bottom. We've got 3 divided by 0. Now that's like a math law that we cannot deal with. So we can't divide by 0, so we actually call that undefined, right? It popped up in the lecture from on oh my gosh, finding the domain, undefined. So undefined. So this is an undefined line. Look, this would be like saying, well, what if I had $3 and I need to divide it into no children, right? That's weird. That's just no undefined. You can't give it to anybody because you don't have any children. So you're kind of it's undefined. That's a kind of a goofy way to think of it. It's hard to grasp. So let's see what kind of line we have here. If we have negative 1, so I'm going to erase this now. I've got negative 1, positive 2, that's about right there. And then negative 1, positive 5 is about right there. But now what's different is the x's aren't changing, right? They're stuck at negative 1. This line is vertical. Okay, this line's vertical, okay? And notice it's stuck at an x value. It's stuck at x equals negative 1. The horizontal is stuck at y equals 4. So I'm going to go one step further with these two. And I'm going to talk just a minute about their equation. Because the vertical and horizontal line have a very, very kind of easy equation to remember. If you're dealing with linear functions or linear equations, actually this isn't a function, right? But if we're dealing with linear equations and they're either horizontal or vertical, the giveaway is what they're stuck at, okay? If you look at this, these two coordinates are stuck at y equals 4. So the equation, let's kind of write this over here. the equation for this line is going to be y equals 4 because it's what it's stuck at, okay? It's what the line's stuck at. Now, down here, we're stuck at -1. It's the x value, right? We're stuck at -1. So the equation for this bottom line is going to be x equals -1, okay? Hard to write down there. But it's going to be x equals -1 because we're stuck at that x value, okay? That kind of pops up throughout this homework and you'll see it again. But if you're stuck at the x or y, it's now, I'll tell you though, this section's titled linear functions. That's not a function, right? The vertical line is not going to be a function. It doesn't pass the vertical line test. So the horizontal line though can be a function. It can be, okay? Questions? Questions up there in Zoom land? Are we good? Okay. So let's move on. So now the next logical step then is let's find equations for these linear functions. We know how to find their slope. Let's find the equation. Now I teach this in a two-step way. Actually, you're always going to have multiple steps. But if you get online, or if you know another way to find a linear equation, you're more than welcome to do it, okay? But I'm going to teach this a certain way, and just to be consistent with it. And I've taught it for like over a decade now. I found this way students can grasp it. It's not too bad. Okay, so the way I teach finding linear functions or finding linear equations is we've got to learn about two different types of equations, two different types of linear equations. The first is called the point slope equation. And you're never going to believe what you need to put an equation in point slope, we'll call it point slope form. Okay, you're never going to believe this. But you need a point on the line and you need the slope of the line. Now you only need one point. And of course, you're never going to have multiple slopes for a distinct line. So you need just one point and the slope of the line, and you can put it in this form. So let's look at an example that lays it out just perfectly for this. And this is number 12 in your book, okay? Number 12 says, use the given conditions to write an equation in point slope form. This will be part A. And then slope intercept form. So let's do number 12. I'm going to teach this with an example. Probably the easiest way to do it, okay? So number 12 gives us the slope equals 4. If you're following along in the book, this is on page 255. So slope equals 4, and it's passing through what was it? No, 1, 3. Passes through 1, 3. So now point slope form looks like this, and it comes from the slope equation. If you just multiplied the denominator over, actually, but it looks like this: y minus y1 equals m times x minus x1. Okay, y minus y1 equals m times x minus x1. And now look, the m is right here, right? That's your slope. We learned about that just a minute ago. This is going to be your x1, y1, okay? Now look, we're going to see an example here in a minute where they give you 2 coordinates. It doesn't matter which coordinate you choose, okay? Either one will work. They'll both be the correct answer. But for us, it gives us the point and the slope. So we're going to put in this form. Now you have to be careful. It's a minus sign. Remember, this is, look, if I multiply this over, it's the slope, right? You guys see that? Y minus y1 over x minus x1. Okay, it comes from the slope. But we've got to plug it in correctly. So let's do that. Now the y, we're going to keep the y. Minus y1 is 3 for us. Slope is 4. And x minus 1 because the x is 1. And now we've put this into point slope form. Okay, that's the part A aspect. Actually, I mean, we can box this in because it's the first part they asked us for, right? put in point slope form. Okay. The next thing they ask is to put it in slope intercept form, which is the most common form of a line, okay? Slope intercept form. Now, slope intercept form is y equals mx plus b. And now, the reason this is the most common form of the line is because it's really written in function form, right? Remember, if we're going to write these as a function, we have to get y by itself, right? We'll call it f of x, but we have to get y by itself. So if we put a line in slope intercept form, it automatically puts it into a function form, okay? Now, the reason we do the point slope form first is it's really easy to go from this form, this point slope form, to slope intercept, right? The goal in slope intercept is to get y by itself, okay? And that's exactly what we're going to do with this little equation. We're just going to get y by itself, and then automatically it puts it in slope intercept form. So I'm going to rewrite this, y minus 3 equals 4 times x minus 1, just to put it underneath. So we solve for point slope form. And now the goal is to just get y by itself. So I'll distribute the 4 first. Okay, so I get y minus 3 equals 4x minus 4, right? And then I'm going to add the 3 over. Okay, I'm going to write this over here because I ran out of room. But it winds up being y equals 4x minus 1. Y equals 4x minus 1. Now this is point slope form, right? Y equals mx plus b. There's the slope. And the b's out here. We'll talk about b here in a minute, okay? But the b is out there. We've done this. Awesome. Okay, that's number 12. And I did ask for both. Point slope form, slope intercept form. Okay? And again, hopefully you've seen this. Hopefully this is a review. Even if it's not, if you've never seen this, I think you could replicate this. If you want to go back and watch this video a few times, just to see the process, that makes complete sense. Okay? But you should be able to do it. Any questions though about this? Pause here for a minute. Okay, let's talk just a second. That b value there is called the y-intercept because it is. That b value is the y-intercept. It's where our line crosses the y-axis. So what's nice about this form, so let's just talk a little bit about it. If I wanted to write this as a function, it would be f of x equals 4x minus 1, right? Now, the question in the book didn't ask me to do this. This is just me going forward, okay? So if I wanted to write this as a function, it would be f of x equals 4x minus 1. And what's nice about this form is we can graph right out of it, okay? We could graph this line right out of this form. We know the y-intercept's negative 1. So our y-intercept is right there. And we know the slope is 4. Now, if the slope is 4, we need to think of it as 4 over 1, right? We need the rise and we need the run. So if I start here, I can go up 4 and then over 1. So let's say I have to start at the y-intercept, not at the origin here. So start at the y-intercept, and I'm going to go up 4 and then over 1. So up 1, 2, 3, 4, and then over 1. And I've got another coordinate on my line. Bam. There's the graph of my line. Okay, kind of neat. Okay. So I mean, it is, sometimes I call it the diva equation in algebra because it's just brought up so often. And in all honesty, it's written backwards. You should have the slope first. Like when we just we should have the intercept first. When we just graph this, we graph the intercept. You have to graph the intercept first, right? You got to have a starting point. And then you graph the slope. And if you ever go on to a statistics class, they'll bring up regression. And the regression equation is the exact same as this, but it puts the y-intercept first, as it should, okay? So I don't know why I'm sure it's some jingle that came along that put the y equals mx plus 2b or whatever, mx plus b, whatever it is. I don't know. But it really should have the intercept first, and it doesn't. And it bothers me, but I can't change it now. Okay? I don't have that kind of pull in the math world. Okay, questions. I want you to try one of these now. I'm going to give you a slope. Look, I'm going to be real lazy here, actually. I'm going to give you a different slope and a different point, and I want you to do this process. Okay, so, and I'm going to steal it straight from the homework. Let's look at this is number 16. So number 16 says we have a line that goes through -5, and it passes through -4, -2. That's -4, -2. So I want you to try this now. Put it in point slope form, and then solve for y to get into y equals mx plus b. I'll give you a few minutes. Okay, keep working if you're working. I'm gonna kind of just come behind you, okay? And then I'll catch up to you, hopefully. So let's see here. Now it's a minus, and we got minuses, so that means that's going to turn into addition. So y minus a -2, so that's going to turn into y plus 2. Okay. Our m is -5, so -5 times x minus a -4, so that becomes x plus 4. Okay. So there's my point slope form. Okay. And then slope intercept form, well, look, guys, I just have to solve for y. Okay. So I'm going to not write it again. I'm going to go on to the next step. So distribute the -5. So I wind up with y plus 2 equals -5x minus 20. Subtract 2, and I wind up with y equals -5x minus 22. Okay, -5x minus 22. So we've got point slope form, and we've got slope intercept form. It's kind of cool. Okay. Look, and I'll tell you, the next few examples really boil down to this. Now, we're going to start out with different what's the word? We're gonna have different can't think of the word. They're gonna give us different examples to start with, like different parts of the line, but then it is gonna come back to putting in the point slope form and then putting in the slope intercept. Like, let's say we do, they just give us 2 coordinates. So I'm gonna erase all of this because it might take a little bit more space. Now they still want point slope and they still want slope intercept, but this isn't gonna be number 12 now. Actually, I'll steal one from them. Let's say this is number let's do a fraction because we love fractions. Let's say this is number 32, -3/6 and 3 -2. Okay, -3/6 and 3. So all they're giving us now are 2 coordinates, but they ask the same exact question. They ask us to put it in point slope form, and then they ask us to put it in slope intercept form. So look, if we want to get this into point slope form, now we got 2 points, right? 2 points, but I need to find the slope. So we've got to do that first. We need that for the point slope form. So I'm going to find the slope first. I'm going to write it over here actually. M equals, now remember this is x1, y1, x2, y2. So -2 minus 6 over 3 minus a -3. So I wind up with -8 over +6. Let's see if I got that right. Well, I got something right. It winds up being -4/3, right? So my slope is -4/3. Let's see. Yep, -4/3. So now, look, it does not matter which one you choose. And I don't know if the book gives you both answers for this, but there's really 2 correct answers for point slope form because it's going to look different for either one of them. But it all winds up in the same slope intercept form. Excuse me. I'm going to just choose this first one to put it in there, okay? So I'm going to say y minus 6 equals -4/3 times x. Now it's going to be +3, right? Because it's minus a -3. So this would be point slope form. PS form. That's point slope form, right? Y minus 6 equals -4/3, because that's our m, times x plus 3. Now we've got to get the slope intercept. So now we've got to get y by itself. So I'm going to distribute the -4/3. So -4/3 x. Now, okay, if you multiply a fraction into an integer, remember that integer is really just a fraction, right? It's 3 over 1, and you multiply across. So this would be minus 12/3, right? 4 times 3 and 3 times 1. So you wind up with 12/3. I'm going to simplify that because it's just 4. So it's y minus 6 equals -4/3 x minus 4. And then the last step, I've got to add the 6 over. Remember, our goal is to get y by itself. So add the 6 over. So I get y equals -4/3 x plus 2. Y equals -4. Now, okay, really, I should box both these in, right? But look, if you chose this other coordinate, your point slope form is going to look different, but the slope intercept won't be, right? It'll be the same. So slope intercept form. Okay. Slope intercept form. Awesome. Yay, the crowd goes wild. I'm going to do another, actually, I'm not going to do another example. I'm going to give you, I want you to do the next one, but I'm going to set it up for you because I tend to have a lot of students ask me questions about this next example when I give it in the homework. And it's, we'll do example, let's do 38. Okay, we'll do 38, which is the last of this section here. So again, if you're following along in the book, it's on page 255. Okay, so number 38 states, oh, it gives us two intercepts. Okay, so it says the first intercept is the x-intercept is 4 equals 4, and the y-intercept equals -2. And again, it wants us to find the point-slope form and the slope-intercept form, okay? The point-slope form and the slope-intercept form. So we have to remember how we find the x-intercept. So I'm glad it went over this because it's a good review. We've got to find out how we get x and y-intercepts. And remember, with x-intercepts, the other value, the other variable is always 0. I should say with any intercept. With any intercept, the other variable is always 0. So if we have an x-intercept, the coordinate here is actually 4, 0. Okay? The x would be 4 and the y would be 0. And vice versa for the y. For the y-intercept, the x is 0. And the y is the variable. Okay, so now that we know that, I want you to go through the process. Find point-slope form. We got to find the slope first. And then put that into slope-intercept form. Let's see if we can use the same exact amount of space. Okay, and I'll give you some time. I'll give you some time to work on this one. So you go. Remember, the first step is you've got to get the slope. You have to get the slope first. Got it? Got it? Feel confident? Feel confident? Okay, let's see. Let's find the slope first. I'm going to do this to the side again, so I'll save some space. Now, this is x1, y1, x2, y2. So we wind up with -2 minus 0 over 0 minus 4. So we get -2 over -4. So I get a positive 1/2. Okay, I can tell you if that's right or wrong. That is right. Okay, it's a positive 1/2. And then again, it doesn't matter which equation you choose. Now, I'll tell you, just for a little trick here, we know the y-intercept. It's -2. We can automatically do the slope-intercept form, right? Because they gave us the y-intercept. Look, this is just y equals, our slope is 1/2 x, and our y-intercept's -2. We didn't have to do all that work, okay? If you did all the work, that's fine. That's what you should have got, okay? And it's because it's a very special example where we were given the y-intercept, okay? Not a single example before this, we've been given the y-intercept. Let's do point-slope form. It doesn't matter which one you choose. I'll just choose the first one. Y minus 0 equals 1/2 times x minus 4, okay? And you'll see, now you don't have to put the -0, but you'll see if you multiply the 1/2 through 1/2 x minus 2. Okay, you get the slope intercept. Pretty nifty, pretty nifty. Okay, any questions about this? Comments or concerns? Okay. Okay. There's going to be some stuff in the homework that you're going to get to, and you're going to go, well, you didn't go over that. But I have, it's just, I want you to come to I want you to use the knowledge that we've gained so far to get to it, okay? You will be able to do it. And we've definitely gone over it, but it's not going to look the same. So I want you to really think about it. It's the last part of the homework in today's section. But I do want you to, I want you to look at it and come back and ask questions. If it doesn't make sense, let me know, and I'll definitely hit it again. But I want to go over some real world questions, specifically one before we do the little part in 2.4 that we're going to go over. And it's one of my, I don't know why I love this question. Or not that I love the question or love, it's a really cool real world example. And it's on page 257. It's number 92. 257, number 92. And you need your books out for this because I can't graph it. So if you don't have a book, I'm sorry, I can't really help you here on this one because it's a scatter plot. It's got all these countries there, but it's number 92. And in this question, let's go through. The y-axis is the percentage of people calling themselves happy. I think there was like a survey or something, and they asked the respondents, hey, do you consider yourself happy? And the percent that replied happy is given on the y-axis. That's the y-axis. The x-axis is annual per capita income for the country. Okay, it's in thousands of dollars. Okay, but it's the annual, or actually not in thousands. It's actually the amount, annual per capita income. So if we look at some examples, just to look at them, like let's do Mexico there. Okay. Mexico, if we look at the coordinate for Mexico, the x value is about, and you kind of estimate this, it looks to me about 7,000. And then the y coordinate, I'm going to say it's like 89. It's right under that, so it's 89%. So what this means is when the country of Mexico has a GDP, annual per capita income of $7,000, and when they surveyed so many of their citizens, they found out that 89% responded that they were happy. Okay, kind of neat. Where if we look at someone maybe in the same kind of annual per capita income but different response, what do you think? Who's about the same per capita income but then not as happy? What's a country there? You guys can throw it out to me. We'll put it up here. What do you think? You guys might be muted if you're yelling into your speaker. It doesn't have to be right at 7,000, but what's a country that's around 7,000 but is not as happy based on the graph?
Russia.
Okay. Kayla says Russia. Kylie, what do you think? I saw you pop in there. I know. What do you think, Kylie?
I don't know, and I'm panicking.
Oh, don't panic. Well, do you see the graph?
Yeah.
Okay, good. So let's look at Russia. Okay, so Russia, if you look at Russia, it's about the same. I'm going to say it's well, you know what? Mexico's probably more like 8,000, right? Okay, I'm going to change this. I think this is closer to 8,000. And then Russia is probably 7,000. You see that on the x-axis? If you go to the coordinate for Russia, the x-axis, it lies on the x-axis about $7,000, right? You see that, Kylie? I'm picking on you now. Sorry.
Yes, I see it.
No one's going to want to chime in because they're going to feel like I'm picking up. Okay, so now, but look at the y-axis. It's about 40, right? I'm going to say 41%. So look, two different countries, Mexico and Russia, pretty close GDP, right? Pretty close, or not GDP, but pretty close annual per capita income. But in Russia, they're responding a lot less that they're happy, right? 89% of respondents from Mexico said they were happy. 41% said they were happy from Russia. Okay? Does that help a little bit? Hopefully.
Yes.
Okay, good. Yeah, just lie to me if not. That's fine. No. Okay, and you can always come back and look at this. But check this out. Okay, now there could be so many reasons why this is true. Culture, weather. I think this is weather, right? Culture, weather, whatever it is. But it kind of gives us an idea of what's going on. Now, let's get to the actual question, though. The question says, let's draw a line that best fits the data. Okay, so we can kind of interpret what's going on. So now look, if you're looking at this data, now I'm not going to draw it specifically, it looks kind of like a triangle, right? I mean, it's all like this. It looks something like this, okay? It's not perfect, but it looks something like that, right? Now, the question asks us to find a line of best fit. Now, what a line of best fit does is like a fence line, and it puts half the coordinates on one side and half the coordinates on the other. This does not have to be perfect, okay? So I don't know if this red will show up, but I'm going to say the line of best fit for this looks to be about like that, okay? And kind of like if you think of this like a pizza slice and you have to share it with your sibling and you have to cut it and they get to choose it and you're going to find that perfect middle cut, right? So that's what we want. We want the perfect middle cut. So many pepperonis or the same amount of pepperonis on one side is on the other side, okay? Well, now when we do that, and you can take a pencil out, no one will look through this book enough, I promise. You can take a little pencil out and you can kind of draw what you think is the best line of fit. And then what we're going to do is we're going to choose two countries to kind of show that, okay? Okay, so let's see so instead of Mexico and Russia, because Mexico and Russia won't line up on the line of best fit. Mexico's like up here somewhere, Russia's down here somewhere, right? We want two lines that kind of line up in the middle. And not in the middle this way. That's not right. I mean, it definitely right. I mean, if you look at this, you could interpret this a little bit by saying, you know what? It's not that money makes you happier. I mean, Mexico's a good example. They're not a wealthy country, and they're very happy. But you could also interpret it like, you know, if you do have a higher annual income, you have a lot less chance of being unhappy, right? I think that's what this kind of graph shows us is, look, once your income increases, you don't see any unhappy countries above, you know, about the 20,000 mark there. You guys see that? I mean, there's no unhappy. It's like you never see an unhappy person on a Sea-Doo, right? It's the same kind of thought. So let's look at this. If we connect the dots here, I'm going to just choose two for this example, and you can kind of see where I'm coming from. I'm going to choose. Let's choose the U.S. Why not? Choose the U.S. It looks like the U.S. wins the annual per capita income race at 32,000. And how happy are we? Would you say 91% happy? I want to say that, about 91% happy. Okay, now we need to choose another country. I'm going to kind of look in the grouping of countries that are kind of by the crust of the pizza. And I'm going to say like Algeria right there. Do you guys see Algeria? I think that would work well for slicing everything in half. You've got to kind of cluster there in the middle. That's not bad. Maybe Egypt. We'll do Egypt. We'll raise it up just a little bit. Yeah, we'll do Egypt. Why not? We'll do Egypt. Egypt, which is, I'm going to say about 4,000 on the per capita income, but it's smack dab at 70 on its percent happy. Okay, so okay. Check this out. We have two coordinates, okay? And it wants us to find the equation of the line that best represents this. And we're going to talk about the slope first, and then we're going to talk about the equation because the slope actually interprets this for us, okay? Or it's a numerical interpretation of what's going on with happiness and with annual per capita income. So let's find the slope first. Look, x1, y1, x2, y2, okay? x1, y1, x2, y2. So let's see here. So this would be 70 minus 91, right? Y2 minus y1 over 4,000 minus 32,000. So 70 minus 1 is negative 21, I believe. 40 minus 32,000. Okay, that would be what? Negative 28,000. Okay, now I know both these are divisible by maybe 7. I need a calculator here. What's yeah. Now they're both negative, so I'm going to turn that positive. This would be 3 over 28,000 divided by 7 should be 4,000. Okay. Oh, you know what? I'm going to put the units on here. Now this was a percent, right? This was $1. Okay. This was a percent and that was $1. But that's our slope. It's 3 over 4,000. What does that tell us? Actually, it tells us a lot. Now, that trend line that we made, the trend line that cuts through, the slope is 3 over 4,000. So what that means is, I'm going to write this down. For the trend line, for every $4,000 increase, because it's positive, in annual per capita income, we can expect, which isn't always true, but from the trend line, we can expect an increase of 3% happiness replies. We'll put that, happy replies. For every $4,000 increase in annual per capita income, we can expect an increase of 3% happier replies. Now, both these are positive, so that's why they're increases. If one was negative, we would say it was decrease. Like, let's say for some reason it was counterintuitive, that if you made more money, you actually were less happy, right? More money, more problems. But if this was negative, it would be like for a $4,000 increase, it would go down 3%, right? It would decrease. Now, we didn't find that. Our findings found that it increased. So kind of neat. So this is an interpretation of slope. This is the interpretation of this slope because it's a real world example, right? The examples we did before were not real world. Okay, this is a real world example. Okay. Now I'm about to erase this, so I want to give you a minute to write it. But because we've got to go on to finding I think it asks to find the equation. Draw a line that best fits the data. Use the coordinates of 2 points along your line to write the slope. Oh yeah, slope intercept form. Yep. So we're going to find slope intercept form. Okay. Let me know when you're good, Kayla. You're not the only one writing. You good? Okay. I'm going to start it over here. So we know the two coordinates. And you know what? I'm going to be a little lazy. Not lazy. I'm just going to write the x value in thousands. So I'm going to say this is 32,091. And the second coordinate is 4,007. So remember, for my example, when I make this equation, my x value is going to be in thousands. And what that means is my denominator for my slope is going to be just 4, okay, because it's in thousands, right? This would be 4 minus 32, negative 28. You divided it before. So I'm going to use smaller numbers just to make this a little easier to run through, okay? I cut this off. So I would get, now I'm going to choose this first coordinate. So y minus 91 equals 3/4 times x minus 32. I'm finding the equation now for this line of best fit, okay? I'm finding the equation for my line of best fit. So distribute this 3/4 through, you get y minus 91 equals 3/4 x minus, need to bust out my calculator. Well, 3 times 32 would be 96 divided by 4, okay? And I think we got real lucky here because 96 is divisible by 4. It's 24. You can check me there. Want to. But yeah, 96 divided by 4 is just 24. We got lucky. And then now I'm going to add the 91. So we get y equals 3/4 x plus, well, 91 plus 24, or minus 24 really, right? What's that going to be? Is that 67? Yeah, 67. So look, hey guys, we found the equation for our best fit line. Kind of neat. Pretty neat, actually. Pretty cool. Okay, for this section for homework, I want you to start at number was on page 255. Section 2 point, was it 3? Yeah. 1 through, I want you to do 1 through 69 odd. You can probably do every other odd and be fine. But 1 through 69 odd. If it's not making sense, do all the odds. And then I want you to do 87, 89, and 91. Okay? 87, 89, and 91. They're the real life stuff, kind of like this one. They're the real life stuff. And I'll tell you, this one will seem a lot easier once you do the other ones. If you're not that comfortable doing linear equations yet, don't worry too much about this one. You can come back and watch this, right? Don't worry too much about this one. Get the basics done first before you get there, okay? And then, yeah. So there's only one thing in 2.4 I want to cover. Man, this takes the whole time. That's crazy. In 2.4 now, I'll leave that here so if you're writing the homework down. In 2.4, we're going to cover average rate of change. Which in my opinion should be in 2.3, okay? Average rate of change. Okay, average rate of change. And we're gonna look at a real world example first, and then we'll use functions. Man, I hope I got enough time. I think I do. I'm not gonna try to rush this. I think 12 minutes will be fine. So average rate of change, let's look at a real life equation, or scenario, I should say. So let's say I was looking at my spending habits, okay?
Your voice is messed up.
Oh, your voice is messing up too. I wonder if it's mine, my side, Jeanette. Are you, okay, you guys in here, give me a thumbs up if my voice is messing up.
I can hear you fine.
Jeanette, I think it's you because when you were talking to me, when you were talking to me, Jeanette, it started breaking up. So I think it might be your internet. If we get logged out, just come back and watch this last part. It'll only be like 10 minutes once it gets in there. Okay, so average rate of change. Let's look at like my spending habits on McDonald's each month. Okay, so oh god, so let's say in January, I spent $20 on McDonald's. Okay, so there's my January spending on McDonald's. And January, February. Let's say in February, I spent $40 on McDonald's. And then I hit that diet. So January, February, March. Use MR for March. I only spent $10 on McDonald's. Okay. And then, so if you want to put the February, March, April, I'm off the diet. I'm back up to $60 a month habit on the dollar sodas. And then let's say in May, we'll use MA for May. In May, or let's use MY. For May, I spend, let's say $40. Okay, so $40. So this is going to be, that's $40 right there. I know it's kind of hard to see, but that's $40. Okay. So look, my spending on McDonald's, it varied each month, right? But you can tell it kind of increased along the way. I mean, if we did a line of best fit, it would do something like that. So to find the average rate of change, you're actually going to find the slope between two coordinates on this graph. And I've got to give you the coordinates. So let's look at this. I want to know the average rate of change from, let's say, January to May. The average rate of change on my spending habits at McDonald's from January to May. And so what you're actually going to find is the slope of the line that goes through these two coordinates, okay? You're finding the slope of the line that goes through January and it goes through May, okay? So look, the first coordinate here, January, we'll call this month 1. If January's month 1, we spent $20, right? Now, if January's month 1, that's 1, 2, 3, 4, 5. May is month 5, right? And I spent $40. So we're just going to find the slope of those two coordinates. So the average, now I'm going to use ARC for average rate of change. It's going to be 40 minus 20 over 5 minus 1. So 40 minus 20 is 20, right? 5 minus 1 is 4. Okay, so we wound up with a $5 a month habit, really. 5 over 1, right? So the average rate of change for each month was $5. So on average, from January to May, I increased by $5 each month. Now that never actually happened, right? I increased $20, decreased $30, increased $50, or $50, decreased 20, right? It's all over the place because it's a real world example. But the average increase was $5 a month along this line, okay? And this is, I mean, if you wanted to look at, which I know right now is like a hot topic, but if you wanted to look at like stock prices, I mean, the same thing's true with stock prices. You know, stock prices are all over the place. Let's look at, I'm going to make a stock up to make the numbers kind of easier. Let's say you buy a stock in January again, okay? So you buy a stock in January and it's at, let's say $30 to make the number easy, okay? And then craziness happens, right? I mean, right now it's kind of crazy, but it's going all over the place. So let's do January, February, March. We'll just do April. But I mean, it's going all over the place, up, down, left, right, doesn't matter. And then in the end, it plummets at the end, okay? Actually, I mean, I'm totally making that. You can make your graph however you want it. It doesn't matter. But let's say it does something like this. And then now we've got a $5 stock. So you bought it at $30 and you're going to sell it in April at $5. Not the smartest investment, but that's just what happens. You needed to get out and get some cash at that time. Now notice, I mean, if we would have sold it in February, man, we would have made money, right? And if we would have sold it in March, at least we would have broke even, but we left it in and it just plummeted from March to April. So let's look at that. What's the average rate of change for this stock from January to April. Because that's all that really matters. I'm thinking if you own a stock, all that really matters is when you buy it and when you sell it, right? It's going to do crazy stuff in between, or it might not. It might be just a calm stock. But it doesn't really matter. All that really matters is when you buy it and you sell it. So let's look at this. So the slope, or I shouldn't call it the slope because it's really technically the average rate of change. Well, the change in the y is 5 to 30, right? If you want to think of these as two coordinates, the coordinates would be 1, 30, and then 1, 2, 3, 4, 5, right? So 5 minus 30, and then 4 minus 1. 30 minus, or 5 minus 30 is negative 25 over 3. Now, just because this example makes more sense with money, I'm going to divide that out. And if you divide 25 by 3, you will get what? Negative 8 point, is it 33? Believe. I think you'll get 8.33. So what this means is on average, we're losing $8.33 a month from January to April. Like if we look at this as a line between these two coordinates, that's what's happening. Okay, that's what's happening. Now, of course, that's not what actually happened. It went up, it went down, it went back up, and it went back down. But in the end, if we buy it at 30 and sell it at 5, 4 months later, that's exactly what's happening. Actually, in a way, 3 months later, but that's exactly what's happening. Okay. Okay, so now let's look at one example with an equation, and we'll call it a day. Okay. And if you get to this in the homework, or when you get to this and you have questions, just let me know. Man, I wish we would have done this a little bit more. Let's look at now a function that's not linear. Let's say we've got f of x equals x squared. Okay. And I'm going to give you a function. I have to give you two x values. Okay. So I want you to find the average rate of change from x1 being, let's say 1, from 2x2 being 4, okay? So this is how the question will be set up. It'll say f of x equals, you'll have some function, f of x equals x squared, which is not a linear equation. I mean, this function, if you wanted to graph it, it's going to look like this, right? It's a nice smiling function. But we want to find the average rate of change from 1 to 4. So really like from, let's say, here to up here. So we're going to find the slope from those two coordinates. Now, what you need, though, is the y values. You've got the x values. We need to know the y values. So we're going to plug in, we're going to plug in the x value to get the y value. So if I plug in 1 to the equation, I get back 1, right? You guys see that? 1 squared is just 1. So for my first coordinate, it would be 1, 1. If I plug in 1, I get back 1. My second coordinate, f of 4, I get 4 squared, right? From this equation. 4 squared is just 16. So the second coordinate is 4, 16. Okay? Now we've got to find the slope from that coordinate. So the average rate of change is actually the slope from this coordinate. So 16 minus 1 over 4 minus 1. So we get 15 over 3. So we wind up with 5. Okay? Now I know I kind of zoomed through that example. We're almost out of time. But I wanted to do that for you. And that way, if you want to see another example, they do some in the book. And if you want to email me and say, hey, there's some good videos of this, I'll send them to you. But if you look up average rate of change, you'll see these all throughout the YouTube and the Googles. But in this section, there's only a few homework questions, actually. 13 through 17 odd. So in the homework on page 267, this is section 2.4. I just want you to do 13 through 17 on. It's only a few questions. because that's just how the book made it. Okay, that's all for the time. I'm gonna stop the recording now. You guys have the homework.